All right. My name is Joshua Bergen. I'm the technical lead for what we call the fleet storage team here at DigitalOcean. Um, this is a talk I had put together for Cephalcon last year, but with all the rescheduling, that sort of thing, didn't work out for me to give it there. Some of the slides here I might go through a little bit quickly. Apologies in advance. I'll try to call out the important details. But this is kind of a story about how we built a tool that we've open sourced a few years ago called PG Remapper that helped us with a number of backfill related issues that we were having internally. And I think it's helped a few other users in the community as well. I'll go to the contents here. So very briefly, I'm going to talk about who is DigitalOcean. We'll talk about the problem that we saw that we wanted to solve with this. And then at the end, I'm going to talk about a few musings that I've had about ways we could change Ceph so we don't need this tool at all at the end of the day. So very briefly, what is DigitalOcean? We are a cloud provider founded in 2012. Initial focus was on infrastructure as a service, so IaaS. We've later added some SaaS offerings as well, such as DBaaS or our Kubernetes offering. What's relevant here is we launched volumes, so that's Ceph, essentially Ceph RBD attachable storage to our droplets. So that's our virtual machine offering. And in 27, we launched Spaces, so that's our S3 offering on top of RGW. All right, so let's start with an augment story, or when something simple goes wrong, or something that should be simple goes wrong. All right, so let's add 4 new hosts. You can see in this diagram, hosts 9 through 12 at the bottom. We're going to be adding to this existing cluster. Each of these hosts is 24 disks. We're adding 96 OSDs effectively to this cluster. So we go through the usual routine here, set no backfill, go and do all the crush updates, and then unset no backfill. And we get this on the right here in our Ceph status. A whole bunch of backfills as expected, but there's only 25 running. And that's curious. Why? We added 96 OSDs. If we have OSD max backfills at 1, we should get 1 backfill per OSD, right? Well, I think everyone here who has run a Ceph cluster before knows that this is not what happens in practice. So we want to get a bit more concurrency going, so otherwise this is going to take forever. Let's assume these are like spinners or something like that. This is going to be a really long backfill. So let's set our OSD max backfills to 3 here. That's better, but also another oddity, which again should be no surprise to folks who have tried to tweak the setting before. 25 times 3 does not equal 110, and yet we now have 110 backfills running, not 75. Interesting, but it's more concurrency, so we're happy with that, and we go to bed. We wake up the next morning to a horror show. There is a whole bunch of backfill that is now degraded, a whole bunch of backfill weight that is degraded, which means our cluster is going to be degraded for some time. We're scared. We reset OSD max backfills back to 1, and then we don't sleep for the next week while the rest of this completes, hoping we never have another OSD or host failure. Otherwise, we're going to have user interruption here. So how does this happen? There's a few reasons why what we observed in the story happens. The first is the way that Ceph manages backfill concurrency. So there's a bit going on this slide. So to set a baseline here, in order to start a backfill, you need to make a backfill will take at least 2 reservations. It takes a reservation on the primary OSD, and then 1 on each target that it's backfilling to. And that's when we're setting OSD max backfills, that reservation amount, that's what we're actually modifying there. So if you look at the backfills on the right here, this is an example of how backfills can get stuck and we don't get the concurrency we expect. So we've got PGs A, B, and C. PG A is currently backfilling. The primary is OSD 1, the target is 2. PGB wants to backfill. Its primary is 3, so it already has the primary reservation, but the target is 2, and we already have a backfill against 2, and so it has to wait. But it's holding that lock on the primary, which is OSD 3. Then we have PGC that wants to backfill. it needs the lock on primary 3. It can't get that because B is currently holding it, even though B is not making any progress right now. So you can see in this diagram, PGC could make progress. It could actually backfill in parallel with PGA, but it can't because of the order that the locks were taken when the backfills tried to schedule themselves. So that explains why we saw only 25 backfills going instead of the expected 96 when we did the original augment. When we increase OSD max backfills, we increase the number of reservations possible, which is great. And that can get us over this problem. But sometimes we have to set it too high, and now we've got too much load in the system. Too high in order to get an acceptable concurrency, I mean. And now we have too much load in the system. And once you have too much load in the system, you have OSDs flapping sometimes, and that's when you get your degradation. Another problem that we found is what I call backfill source overload. So you notice in the last slide, I say that we take a lock on the primary and the target. We don't take a lock on the backfill source. For replicated PGs, that's fine, because for replicated PGs, the source is always the primary. So the primary reservation acts as the source reservation. For EC, it's a totally different story. If you look at this diagram here on the right, I've highlighted the OSD movements that are happening on a per PG basis. So for example, PGD data is moving from OSD4 to OSD5. In EC, OSD4 in this case would act as the backfill source, but there's no lock taken on it. So you can actually see we actually have 4 backfills currently happening that are using OSD4 as a backfill source, even if we have OSD max backfill set to 1. In theory, there is absolutely no limit on the number of backfills that could be happening where a given OSD is a source for those backfills. In practice, because of all the other limitations and how many backfills that can happen, and just like randomization with the system, usually this doesn't happen too much, but we have actually seen this happen before. And again, overload means flaps, et cetera, and degradation. Another issue we've seen is waiting recovery. So for example, we have a backfill going, and that could even be a clean backfill, but then we've got a number of recoveries that are waiting for the reservation in order to get themselves done. It would be really nice if those recoveries could actually just go ahead, because they might only take a minute, even though this backfill could take hours. And so some degradation that can pile up in the system can last much, much longer than it needs to, simply because of the ordering of the locks. Yes, the recoveries have higher precedence if everything had a fair chance. But once the backfill is already going, or if they're stuck behind some other backfill weights, they don't even have a chance to contend for those backfill locks in the first place. And then finally, degraded backfill. So for example, here's a case where this PG is degraded. We're also moving data from OSD3 to OSD4. If we were not moving data from OSD3 to OSD4, this could have actually probably been a recovery. And the recovery would have, taken seconds, versus this backfill is going to take minutes, hours, however long it takes in this particular system. So it'd be really nice if it could actually pause the backfill, do the recovery, get back to the backfill, just so that we're actually clean more of the time. So those are the problems that we have observed. And that's kind of the culmination of those problems is what led us to write PG Remapper. So this is just a summary of all I talked about. I'm going to skip ahead. Yes, maybe, Brian. We'll get to that at the end of the show. All right. So PG Remapper. Basically, the whole concept behind PG Remapper is to control backfill via the upmap exception table. This is not our idea to start with. Dan Vandister did a talk, I think it was November 2019, where they talked about doing exactly this as well. They have some scripts that they had open sourced in order to do some manipulations of the upmap exception table to be able to control backfill. We basically took that idea and expanded it for a broader set of use cases that we were encountering or we anticipated in the community. This means it should work against Luminous Plus, because Luminous is when the upmap exception table was introduced. I have the website here. Our README has a little bit more details on precise versions that we recommend to be running if you ever want to use this tool. There's 2 major concepts within PG Remapper that we've built. One is the mapping state, and then the next slide is where we're going to talk about the backfill state. So there's a lot going on this slide again. Basically what I'm showing on the right here is on top of the dashed line is what is Ceph's current mechanism for viewing and manipulating the outmap exception table. Basically, it's a very simple API. You can see, for example, two PG outmap items there. So PG 1.7, it's saying data that would have, or PG assignment that would have normally happened for OSD 74, assign it to OSD 148 instead. And the only real ways to update this is either to set a new row. And so, for example, if you wanted to add another remapping for OSD for PG, 1.7, you would have to go PG 1.7, 74 148, because you need to retain that mapping, and then you add your new mapping at the end. Or you can just remove the mapping outright by using RM PG outmap items. Pretty simple API. A little bit hard to work with manually, though, if you have to work with it at scale. Say you've got tens of thousands of PGs or something like that. So inside of PG Remapper, we basically have something that builds up the upmap table state internally and then exposes a simpler API, which is I want to remap for this PG from this OSD to this other OSD, and it figures out the delta that it needs to apply to the PG upmap table in order to achieve this. And if you use the tool basically in its default mode, when you tell it to do something, it will spit out the delta in some sort of like diff-like format to tell it what it's going to do. And then you can say whether or not you want to apply it in a separate run. Backfill state, this is the other part of our solution. So this looks at the current state of acting sets and upsets in the PG states to figure out what backfills are scheduled in the system. Prior to Octopus, you have to use local admin socks in order to get to directly query what backfills have been scheduled and what the reservation status is. And because we wrote this tool to work with Luminous Plus, we don't use that. We infer it from a PG dump effectively. And then the reason why we build this, and you'll see this in some upcoming examples, is it gives us control where we can say we don't want backfill weight ever. Backfill weight is bad because anything with backfill weight is, again, per previous slides, holding locks that they shouldn't be, potentially, or they could become dirty and there's no way, and unclean, and it takes a long time for them to get scheduled. And it's just inefficient, right? So basically, we use PG Remapper to avoid that. And by having this backfill state within there, we can make predictions about if we go and start backfill X, is it going to get scheduled now or not? And we always want to stay within that bound if we always want it to be schedulable at any given point in time. All right, so putting it all together, this help here on the right is pretty dense. I'm giving an example of one of the PG Remapper commands that we can run here. So I'm going to go through it bit by bit. Here is the drain command. The drain command basically says, I want to move PGs off of the named OSD. So you have a source OSD you provide there. Target OSDs, you can list any number. We have a concept called an OSD spec, which I think might also exist in Ceph, but it's probably a different concept, confusingly. But an OSD spec is basically you can give an OSD number, or you can give it a crush bucket. So that could be a host or a rack or anything you have in your crush map effectively. So you can say, I want that as my target. Then there's some other hints that I'm not going to go into too much, but you can kind of give it hints about what levels of the crush map you want to allow data to move across. And then you also tell it about the max backfill reservations you want to be able to consume by this drain operation. And so that uses that backfill state I just referred to. And that the backfill reservations, so that's primary and target. And then max source backfills, that's the source issue I was talking about earlier. That's counted separately. How many backfills do you want to allow on a per OSD basis when it is the data source? And it knows how to figure that out between replicated or EC cases. So as an example here, PG Remapper drain 14. So we're going to say start moving PGs off of OSD 14. We want to move them to any OSDs in host 5. max backfill reservations, system-wide setting of 2, but we're going to allow up to 5 backfill reservations on OSD 14. Maybe we're going to increase that setting or something like that within the system, and allow up to 5 backfills off of the source there. So that's basically the syntax of that command. I use this command as an example because I think it's one of the easier ones to explain, but we actually find in practice that drain isn't all that useful. There's actually different ways, different commands to use, or sub-commands to use within the tool that we found to be more useful actually in practice. All right, so let's try that augment again that we were trying earlier. So you can see on the right here, we set no backfill. We do all the crush movements. But before we unset no backfill, we use a command called cancel backfill. And this will take as much as possible everything to active clean again. This basically modifies the upmap exception table to reverse any backfill decisions that Ceph has made from the crush changes. So now you can have a mostly clean system. I say mostly because once you start to have certain cross-map rack movements, or I don't remember probably my limitations slide here, but there's something we call PG swizzles. I'll see if I can get to that in a sec. There's certain cases that we can't cancel just because of the limitations within what the upmap table is capable of. But this usually gets things mostly clean. Then you can let that backfill go before you start new stuff. Or you can start using PG remapper because it knows how to interpret the current system state. Anyways, hopefully everything's active clean, no backfill. Then we use something called undo upmaps, which basically looks at any of those upmaps that we just set on those new hosts. So we're saying undo the upmaps on hosts 9 through 12. Again, backfill reservation, source backfill settings. And now it knows how to schedule those backfills for maximum concurrency. So you can see an example here. We now have 288 backfills going in parallel and no backfill wait at all coming out of that command. And then the idea is you would run this command in a loop effectively in a script somewhere. We've talked about maybe adding that looping internal to PG remapper, so you can basically run it like daemon mode or something like that, but we've never really gotten around to it. And the thing is, in your scripts, you might want to check for certain health conditions or have exit conditions and that sort of thing. So it's not straightforward to add that into the tool. But anyways, this is an example of how to make that augment cleaner. And then let's say you also have disaster strike and you have degradation again or something like that. Kill your loop, run cancel backfill, everything goes back to clean. Backfills will actually flip to recovery out of that, and then you can have a clean system quicker that way. And then or you have to stop for maintenance. You have an option to stop for maintenance mid backfill too, especially if this is like a week-long operation. Just briefly talking about other supported operations on the right here, and you can look at the README on the GitHub page for more information. Balance bucket, this is just like for it, you can tell it to rebalance a specific crush bucket rather than using the Ceph balancer, which touches everything. We've had a few use cases in the past where this has been necessary in larger systems that might have been in a weird state when we inherited them. You can import or export the current upmap state for any number of OSDs, which is useful for some operations. And then that remap API that's internal that I talked about earlier, we also expose it as a command line tool if you just want to quickly go and do some manual upmap manipulations, that sort of thing. Okay, yeah, so I didn't have my limitations slide. The one thing I wanted to point out is there's something that we call PG swizzle, where let's say you have a number of crush changes. You can actually have a PG that's swapping an EC that's swapping, like say OSDs 3 and 4 within the PG, and that causes backfill from 3 to 4 and from 4 to 3. And I don't know of any way to cancel that using the upmap exception table because it basically sees those like, it's almost like it parses the upmap entry linearly. And so you can't have a upmap entry from 3 to 4 because now there's 2 copies on 4 effectively. So upmap exception table can't cancel those. Those don't happen too often, but when you're doing augments, they do show up. So that's just a case. Now, this is just a number of ideas. I have no idea how feasible these are within the Ceph code base. But I think like basically implementing these in some form would eliminate the need for PG remapper in the first place. The first one, so the first problem we talked about was lack of backfill concurrency. This is in some ways a very classic multi-lock problem where if you're taking multiple locks, you can have these issues where you take some and then you have made only certain progress, and then other things get blocked as you're trying to make progress gathering more locks. A common technique for this is back off. If you try to acquire 3 locks and you can only get 2, you actually undo those first 2 locks, set a timer, and then come back to it again. If this would work, this is actually a pretty simple solution to basically maximize backfill concurrency within the system. Oh, maximize with an asterisk. The one nice thing of the PG remapper is it can take a global view before it injects a set of backfill into the system. Because OSDs are making independent decisions, they could still make suboptimal decisions, but they should make more optimal decisions than without doing this. Backfill source overload, another straightforward. I'm putting straightforward air quotes around anything I say that just are straightforward here, because again, I know that distributed systems are hard. But the straightforward solution would be to add reservations to backfill sources as well, at least for EC PGs. A downside of this is this would exacerbate the multi-reservation problem. Now you have even more reservations you have to get, right? So I would suggest that if we do want to consider this, we probably want to solve the multi-reservation problem too. Otherwise, it's going to make concurrency even worse. The waiting recovery problem, couple options here. If the state machine could allow backfill to be paused when recovery is waiting, would be great. Another option is to basically subdivide the number of backfill reservations within an OSD so that you always have something reserved for recovery. When we're using PG Remapper, we basically do this in practice. We usually set the maximum concurrency within PG Remapper to at least 1 less than the system setting. And that way, if there ever are any recoveries that pop up due to a flap or like a host issue or something like that, there's always room for them to actually progress while the backfill is going on. The second option is simple, and it might be good enough, but on slower systems, maybe you don't even want a backfill and a recovery to be happening simultaneously. Hard to say. And then finally, degraded backfill, like I pointed out, as long as it was originally possible for a degradation to be cleared by a recovery, PG Remapper is able to turn these backfills back into recoveries, which has been very useful for us. So it seems to be that it'd be possible to have the PG state machine be able to do this as well. Again, maybe pause an ongoing backfill so that it can do a recovery for one of the OSDs before it resumes. But I have seen the PG state machine, so this is probably a complicated problem to solve within that context. All right, so that's the end of my presentation. I think, Laura, we were going to hold questions until after the second presentation. Is that correct?
Yeah. If anybody has any questions for Josh, please add them onto the Etherpad, or if you want to speak at the end, that'd be great. And thanks so much for this awesome presentation, Josh. We're honored to have you share PG Remapper. Oh, thank you. I was hoping somebody would share the link to it as well.
Yes. Thanks, Alex. I had that same thought too. Yeah, thanks for your time.
Thank you so much. And I'd love to have a copy of your slides at some point so I can put it on our Ceph.io page.
Sounds good.
Thanks so much. All right, so our next speaker for today is Pedro, who will be demonstrating some new dashboard behavior with CephFS management. Do you want to take that away, Pedro?
Yeah, exactly, Laura. Thanks, everyone. As Laura mentioned, I will be presenting to you right now. Let me share my screen. As you can see, one of the newly features we have added.
I still can't see your screen if you have it shared.
There we go. Should be visible right now. Perfect.
Awesome.
Okay, so as I was saying, I'm a software engineer at IBM, and my team and I work with Ceph Dashboard. And recently we have added this new CFS management in Ceph Dashboard. You will be able to work with it now in the new and latest version of Ceph for Riff. So let's see what the new features include. One of the few features we have added recently are management for file systems, volume groups, and subvolumes. So these will be the things we will be looking at for today. And hopefully we can explain and see how everything goes and later on I can get everyone's feedback and their thoughts on it. So let's go ahead. First, we have one of the three main operations we can do for the three different things as we saw, file systems, subvolumes, and subvolume groups. We will be able to create, edit, and remove. Right now we can see the create option operation for the file system, where we can place our name and select one of the placements. We can either choose from labels or host. And after that, we can already create our file system. After we have created any of these three categories on the CFFS, we will be seeing one of the notifications on the top right, and you will be seeing all over this, all over the presentation. So hopefully we can see them all along. So now if we skip to the edit part, pretty simple. The only thing we can do for the file system will be to rename it. We have different UX and UI options to help the user, as for example, the ability to set the to invalidate name unconventional namings and allow just specific characters that are able. This will be an option that we will see as well for the three different categories. As well, we can remove, as mentioned, the file system previously, and we will get a pop-up indication that if we are sure that we want to remove it, just in case some additional two-step removal. So next, we'll see what we have in a file system, what we can see in the dashboard. There are different things in the first tab we can see on the top, on the details tab. We can see the ranks, pools, standbys, and a graph indicating the MDS performance of our file system. There are multiple tabs in the file system, as we are going to see, like the subvolume groups, clients, directories, and the performance detail, which include our Grafana panels integrated in the dashboard. Now we will see a little bit more of each one of them. As for example, we have the subvolume groups management. Here we are, let me go back. We are creating a subvolume group, and we can see the different options we have for it. These options will be the same for subvolumes, as we will see later, since both share the same capabilities, or almost all of them. So we can set the name, we can set the volume, name, size, pool, UI, GD, and of course the mode. These are all the options we have the ability to use for the CFFS subvolume groups creation, and these are the options we will see. As you can see, we have different tooltips on the left that you can hover over, so we try to explain as best as possible the different categories and options we have. And as always, after creating the subvolume group, we will see the notification on top, indicating that everything has gone right. If not, we will see the catch error and we will display it like we usually do on the dashboard. So now we can see the listing of the subvolume group we have created and the different columns displaying the different information we showed earlier. As the name, that's a pool that it's associated or is in with the subvolume group, and the usage. We can also edit the subvolume group, and the only option we are able to edit for subvolume groups will be the size. So that's the only option available for editing. So let's look up the subvolumes management. Same thing more or less goes in here. The only difference for now will be that the groups are displayed on the left, since we will be selecting the subvolume that for the group we want. So the new addition for this form we have here in comparison to the subvolume groups would be that we have the subvolume group, which this subvolume will be set into right. Here I'm looking into it, and I'm setting it for the group one we just created. I leave all the options as it is and create it. And we can see once it's done and loaded that it pertains to the group 1 we just created. Same thing, we can edit the subvolume to edit its size, and that will be set. So these are the two of the main options, or sorry, capabilities of the subvolume management. One of the next ones will be the subvolume snapshots, as we are gonna see. So of course we can try to work with snapshots. We have the directories page here on the right, as we showed earlier. And this will be where we will be able to set quotas and snapshots. Here I'm creating one snapshot for the subvolume we just created. And then snapshot for the subvolume will be set. So the next thing we will be looking at is the subvolume snapshot removal, because when we have different subvolumes with different snapshots, with subvolume with different snapshots, we want the ability to remove those. We might want the ability to remove the snapshot or not. Oh, sorry, this repeated. Oh, it's the next one. Sorry about that. This is a video I was hoping to show. Here we are going to see the last operation we can do with the subvolumes. Same thing will be this for the subvolume groups, except that here we can hold our snapshots and remove the subvolume. As always, we show the pop-up when we try to remove anything, just to make sure that the user wants to remove it. And a new option is shown here, explained by a tooltip, where we can see that we have the ability to retain the snapshots and only delete the subvolume. Since it's not possible to remove a subvolume without retaining the snapshots, an error will happen and we'll catch it to show it and let the user know that this is not possible. So if you desire to remove the subvolume, you will have to retain the snapshots. Once that's done, the subvolume will be removed, but a listing for it will still kept on the dashboard. So the user can still know that the subvolume is still there because it has snapshots. So these are the three main features and three different categories for subvolumes, subvolume groups, and file systems, with the ability to create, edit, and remove them. It's one of them to be able to work with the dashboard more easily and the CFFS. So in the near future, we are actually actively working still on it. We are hoping to get a better listing for the snapshots and better abilities to manage them. So we are hoping to add snapshots creation, editing, deletion as well, and listing for every one of the subvolume groups. So it will be easier to work with them in the future. And also we are planning to implement some mirroring management for the CFFS within the dashboard. So I think that's it from my side. So a big thank you to everyone listening to me today. And hopefully we can get some feedback from you guys and from everyone to keep improving the Ceph dashboard. Thanks, everyone.
Thanks so much, Pedro. So yeah, if anybody from the audience has feedback or questions for this feature, please add it to the Etherpad and we'll get to it all in the Q&A. Great demonstration. All right, so we'll use this last part of the meeting to go over some questions that people have had. I'm pulling up, so I don't see anything. I see something about the Pacific end of life, so we'll get to that at the end. But first, let's circle back to Joshua's presentation about crush changes at scale. Was there any questions that people had for Josh? Dan, go ahead.
Sorry, just getting my mic on. Yeah, I mean, okay. Yeah, thanks, Josh. That's really great. think it's really cool how you took the idea and took it to the next level, and all of the work that you did regarding like finding the good schedules that will like do the recovery before the backfill. I think that's all great stuff that probably should eventually go into the OSD. But I had one question, because I noticed that you guys think about the, like, let's say in your augment use case, you think about the way to get to the final destination. You think about it differently than I always had. I noticed your, what was it, like undo upmaps command, because the way that I've been using this kind of tooling in the past is to, let's say, cancel the backfills like you do, but then like only do that, then just rely on the MGR internal OSD balancer to remove the up maps that are keeping the like new augmented OSDs empty. So like the internal MGR balancer will just remove those up maps that are moving data away from an underfull OSD. So I'm wondering if you guys also use that. And I mean, I guess together with this, the second thing is that, and I think maybe you indirectly mentioned it, but like, don't you guys agree that this kind of tooling, like cancel backfills or upmap remap, as I called it, should just be like a core feature of the OSD, so that, for example, if you add a lot of capacity to a cluster, it shouldn't result in like a huge percentage of remapped PGs. It should throttle that. It should use upmap to create all the upmaps, so that the percentage of remapped PGs should always stay under some threshold, like maybe 1% or 5%, as all of the new tooling regarding like PG splitting does. So yeah, just curious to hear your thoughts about all that. Thanks.
Yeah, for the first part, and this is something I probably should have addressed in the slides, using the rebalancer to effectively perform the augment afterwards. It is something we've experimented with internally. I think we've had two observations around that. One of that is, especially in the early days, it was usually too conservative in its parallelism. That's gotten better, especially with like the target max displaced ratio and that sort of thing affecting it. The other thing is, unless this has changed, I don't think it avoids backfill weight. We're basically like completely allergic to backfill weight within our environment, and it does not make decisions that are beholden to the reservation system. So those are two strikes against us using that broadly. The other one, and this is very minor, I think when we first started using the upmap exception table, I feel like maybe the community felt this way as well. There was like a feeling that we should reduce its usage as much as possible once it's in steady state, just in case there were side effects. I think now at this point, we basically assume there are no side effects to having a larger upmap exception table. But we observed that using our undo upmaps method followed by a rebalancer being turned on instead of using the rebalancer actually ended up with fewer upmaps in the exception table in the final resting state. We didn't look into why, but that seemed to be the case in our experiments internally. Yeah, so that's for your first part of your question. Second part of your question, I mean, I think what you're proposing would fit really nicely in how Ceph now manages things like PG splits and merges, as well as rebalancing, all using the max displaced ratio to basically control concurrency there. So I think your proposal would be fine, and maybe arguably it's even easier to implement than some of the ideas I presented at the end of my presentation as well. I think my only, yeah, you could have that built in. One thing that we've always wanted, and this is something else I also did talk about in my presentation, is the ability to, that cancel backfills thing in your script works the same way. You basically have to iterate everything and then just like, we do this concurrently because it takes forever in large systems, but just add more and more entries to the upmap exception table. We would love a way to basically just upload an upmap exception table that we want in its final state. And so basically one OSD map sent out basically undoes all the backfill at once, right? Because like all those OSD maps being sent out is disruptive too. Like we we don't actually do this on RBD systems today if we can help it, because the latency cost is too high. So anyways, yeah, what you're proposing would work too, and it means fewer changes to things like the PG state machine or backfills and that sort of thing, and would be a reasonable approach as well. Yes, Neha?
Great, thanks. Yeah, great. I mean, I agree with all that. Actually, your idea about the like one epoch multi-up map, that sounds like a really great idea, and a good low-hanging fruit, I would say. Just extend the PG up map items command line to take multiple sets somehow, or make a different flavor of it. Yeah, great. Thanks a lot.
Okay. I think Neha was going to say something.
Yeah. First of all, thank you for your presentation, Josh. It is really useful. I agree that a lot of stuff that you're talking about should potentially go within the OSD behavior and not an external tool. A couple of things that I just want to highlight is one of the things, the max target misplaced ratio. The balancer already uses that as a metric to see how much changes it makes, but it doesn't do it more effectively, is what you're trying to claim, right?
Yeah, exactly.
Okay, so that's one thing. And the second thing I wanted to talk about, you mentioned one thing in your presentation about the amount of time the PGs are in degraded state, therefore they cannot get to backfilling. With mClock, that has changed. So there have been optimizations which are going to be in 17.2.7, where the amount of time PGs are in degraded state is going to be as minimal as possible with the settings that we are applying. But yeah, the backfill rate problem is not being addressed, but the first part is being addressed. Just something I wanted to highlight.
Oh, that's really cool. And sorry, I missed what version you were saying that was going to be
It's
available.
the land in 17.2.7, the release that we are currently trying to publish.
Nice. Yeah. Okay, that's exciting. That's good to know.
Yeah.
And it's probably worthwhile to also mention that in Quincy, the recovery options, basically the max backfill, max recovery active options, they're now gated by another option called mClock override recovery setting. So if you want to, if anybody wants to modify the max backfill or recovery settings, they will have to first set this override option and then go ahead and make the changes that they want to make. That's one thing to keep in mind.
Yeah, that's why I was asking Josh whether he has tried this with Quincy, and I just want to make sure we are not breaking something unintentionally with mClock, right? I mean, there are some assumptions around max backfills that you're using. It would be cool to try it out.
Yeah, because PG Mapper doesn't directly interact with max backfills, I think it should actually just still work the same way. But it'll be interesting to see what its interplay is between the choices it makes and then what mClock chooses to do
exactly
with those choices. Yeah, exactly. Yeah, we haven't tested those. We haven't tested those two together yet. We're still Pacific based, and we're going to be jumping to Reef probably next, and then that's what we'll have some experience to see what happens.
Even better. Reef has all the good stuff.
Josh, it was a really great presentation. One thing I was curious about was we were talking a bit about some PGs like getting stuck behind backfill when they could be recovered more quickly. I was wondering in which circumstances was that a concern? Is it kind of because you're monitoring the number of PGs that are in some kind of abnormal state, or are there PGs that are kind of have less redundancy than they should, whereas these backfills are kind of just adding more capacity? Or
the issue is basically like anytime you have anytime we have a degraded PG, that means that we have reduced redundancy, and another failure could cause inactive PGs. Like that's really the concern that we're driving at. And most of the time when we're seeing degradation during a backfill operation, it's often due to OSD flaps. And so if one OSD flapped, another one's going to flap somewhere. And all it takes is for it to flap in a different failure domain. And also now we're below min size or something like that. And we have inactive PGs. So reducing the window that we have degradation, especially during these stressful operations. And this has been like more of a problem in our spinner clusters, but like just in object clusters in general, because of the high object counts. we've seen this even on Flash sometimes too, where we really want to reduce the amount of degradation that's in the system and the time that it lasts.
Yeah, that certainly makes sense, and I can certainly see why like the backfill decision points where currently we're only choosing among different PGs to schedule for recovery after the reservations are free. That's kind of the bottleneck today.
Yeah.
So I do like your suggestion about kind of separating the reservations between recovery and backfill. I think that would be a pretty simple way to handle it.
Yeah, it seemed roughly simple because I did actually look at this code. You probably remember, Josh, you and I interacted on the mailing list, I want to say 2 years ago now or something like that about this topic. And I did look at the code at the time. It looked like it shouldn't be too bad, but I mean, I'm not an expert in this code base.
Yeah, there are certainly potential pitfalls that need to be worked through in testing.
Yeah.
But it'd be much simpler than revamping the whole reservation system itself.
Yeah, for sure.
And one other thing that I think Dan brought up as well was about being concerned with having remapped PGs. Why is that a concern, or is it kind of a symptom of something else?
Sorry, I'm not following.
I mean, it was like, it's basically, I don't remember the slide numbers, but it's basically like the problem, which is that was demonstrated by like all of the undersized PGs appearing, because it's quite common that when you do, like, say you add a large number of hosts to a cluster, things start out well. You have a large number of backfill PGs, but then you come to work the next day or in a couple days, and something's happened, like some OSDs have been overloaded or something's flapped, and then you now have undersized PGs, and those don't get resolved for a long time. So you start accumulating OSD maps, and things just like don't resolve. And in large augments, it can be a state that lasts for weeks, and it's just stressful. So getting back to health okay, like on a daily basis, like really eases the peace of mind of a Ceph operator sometimes.
Mm-hmm.
Yeah.
Okay, I missed the undersized addition as well. That's definitely more a cause for concern.
I did see one question asked in the pad here. The question is, any ideas of how PG Remapper could work with the balancer so removing the maps doesn't cause some OSDs to become too full? The mode that we use it in today, we just haven't run into that problem, is the not helpful answer. If you're worried about that, I would suggest using Dan's approach instead, which is, instead of using undo up maps, do the cancel backfill, and then use the Ceph balancer to do the actual like augment work, so to speak, afterwards. That is the safer choice. But as long as you're augmenting well below full thresholds, this doesn't happen. We haven't seen this really happen. And then the other side of it is like, especially after Nautilus, Ceph is just a lot better at predicting when backfills shouldn't happen because things are starting to get too full. So you're usually pretty well protected against disaster that way.
The problem that I run into is that if you use that method of using the like upmap, remapped, and then rely on the balancer, sometimes the balancer will try to like move data onto OSDs and then also remove it from those same OSDs.
Mm.
So you end up with like a whole bunch of extra upmaps.
Yeah, and maybe that would explain why we saw sometimes that there were extra upmaps after using the balancer rather than doing undo first and then upmaps. That would explain that. If you saw in my example, we're very specific when we do our undo upmaps. We are very specific in which OSDs we're targeting there to try to avoid too many like back and forths and that sort of thing. So you definitely end up in a suboptimal state at the end of that undo upmaps loop, and then the balancer kicks in and gets you back into a better state after that.
Yeah, something on this that I've thought for a long time. I guess it's something for the MGR balancer. It is you do often hit like let's say a local optimization point with the balancer that might not be the the global optimal. So I've thought for a while. I mean, I understand this is at the risk of like having like patch on top of patch on top of patch and not solving the problem from the root cause at the beginning. I've often thought that the MZR balancer should just like periodically remove a random set of up maps just to like try to break it out of like a suboptimal state. Just to try harder to trim the up maps and try different approaches to get to optimal, to an optimal balancing with minimized up maps. Yeah.
Yeah, it's a good point. So you're saying you've noticed a lot of scenarios where up maps are added, but you see more efficient ways of being able to do it, or there's some redundancy there essentially with what up maps are put in the OSD map.
Yeah, that's right.
Okay, interesting.
It's exactly the scenario Brian just mentioned, that you have like you add a PG to an OSD with one app map and you remove it with another, and that's a redundant.
Right.
If it's for the same pool, that's redundant.
Definitely, I see what you mean. And yeah, it may be correct, but I can see why you would want something more streamlined, especially if there's data movement going on. I think definitely to track some of these items, we should create feature trackers just so we have record of that we want to address these problems. So that's something that would help if users, if you could do that, that would help us developers track what we want out of this. So if you want to go ahead and create a feature tracker, that'd be great. Awesome. Was there any more questions that people had for Josh or also for Pedro about, or if we've finished with the PG remapper questions, we can move on to dashboard feedback. All right. Looks like we can always go back to it, so let me know. As for the dashboard demo, I thought I didn't have any major points to say aside from that I thought it looked good and I thought it looked interesting. But if anybody is an avid Ceph management person, feel free to speak up. But yeah, I thought the demo was great.
Thanks, Laura. Anyways, if there are no questions for today or feedback for today, you can always reach us offline on the different Slack channels we have for the upstream. So feel free to do so whenever.
Yeah, or if there's any particular aspect of it, Pedro, that you were looking for feedback on in particular, that might help to specify. But it seems like the overall reaction seems good.
No, any particular point would be great. So no, any particular specific. But thanks anyway, Laura.
Awesome. Yeah, if anybody thinks of anything after the call, feel free to send a message to the Ceph users list or the Ceph develop list, and that'd be great. All right, I'll address this last topic that was about. Oh, thanks, Neha. There's a link to join the upstream Slack channel as well if you'd like to add any discussion there. That'd be very much welcomed. So we have this last point on the open discussion pad about the Pacific end of life. It says many PRs from the start of spring 23 were added and that they need attention. The final release for the end of 2023 or a new EOL. So we are planning, I think in a previous user dev meeting, we had said that the last Pacific release was we were thinking that would be the last, but we are planning to do one more point release. And right now we're prioritizing Reef, but Pacific will be next. Is that right, Neha?
I missed the last couple of CLT meetings for several
Oh.
reasons, but if anything has changed since then, I'm not sure. But the last time we talked about it, I think there was we wanted to get Quincy out and then Reef and collect all the final PRs for Pacific and do one release, one final release that would be, including everything.
Right.
So please,
So for,
if there's anybody who has a different opinion, please correct me.
yeah, that's right. So I'm going back to when we had talked about it. And so right now we're wrapping up 1727. The next on the list is 1821. And then after that will be 16215. And we've started this this pad to track. We're doing a testing cycle just as we always are for these PRs. If anything has a NIST QA label and has been approved, it will be tested. But you can also add to this Pacific 16215 pad. And this is helping us track any must-have PRs for that upcoming release. So if there are any PRs that you feel absolutely should get in, feel free to add it to that pad and we'll prioritize those PRs essentially. But yeah, at the moment, there's no definitive EOL, but the definite order of the next releases is 1727, then Reef, then Pacific. Thanks, Neha. Yeah, but these are additional pads that you can add to as well for 1821 and 16215. I'll add these to the user pad. Mark's hearing random music. I don't hear random music either. Interesting effect. All right, so it looks like that was the last point on here. Was there anything, we've got 3 minutes left, but was there any closing remarks that people had about our two wonderful presenters today? Claps. Awesome.
That's the sound we want. Yeah, very big thank you to both the presenters for coming and taking the time to present with us. Really useful. Thank you.
Yeah, we really appreciate you sharing your time with us. And we had a user today give a talk and a developer. So that's exactly what we want, engagement from both sides. And if you have a topic that you'd like to present at a future user dev meeting, here is two developers, thank you. We've got this link here that you can submit to your topic to. So we'd love to hear any kind of topics that you guys have coming in, and I really appreciate it. And I'll see you guys next month.
Laura,
Thank
thanks
you.
everyone.
Thanks, Laura. Thanks,
Bye-bye.
everyone.
Thank you.